Okay, let us talk about Pluto. So, Pluto is classified as a dwarf planet, and the reason for that is it has a very oval shaped or elliptical orbit to it, and that orbit is tilted from the plane of the ecliptic. So, it doesn't follow the same quote unquote rules that our other planets do to be classified as planets in our solar system. So we have now classified it as a dwarf planet. And this dwarf planet is about 1400 miles or 2,380 kilometers wide, which is about half the width of the United States. It orbits the sun about 3.6 billion miles away in a region called the Kuiper Belt, and we'll talk about the Kuiper Belt a little bit later. The orbits are 248 Earth years long, and it rotates every 153 hours or about 6 Earth days. Okay, so it's very slow rotating object. It has a very thin atmosphere of nitrogen, methane, and carbon monoxide, and it has 5 moons, no rings, and the surface is much too cold to sustain life as we know it, being negative 378 degrees Fahrenheit to negative 396 degrees Fahrenheit. Okay, so it's a very, very cold surface. And with such a cold surface, we will have um, a lot of ice that forms, and it may not be water ice, but it may be nitrogen ice. So up here, um, this is from your textbook, and I believe this is going to be your nitrogen ice that is in this kind of like level plane here. It's kind of grayish tone. And then these sharper objects here is, I believe, water ice. And so this water ice is kind of acting like a glacier in this other ice form due to density differences. Okay. And we can see this very interesting surfaces, these differences in surfaces on Pluto. So we've got all of that, which is very icy. Then we have this apparently more rocky surface with craters. So we see a lot of cratering that has happened from impacts. Okay, this area here is still being kind of thought over, I guess we could say. Still looking at it, trying to figure out what is going on here geologically. And here, down in the bottom left, or right, sorry, the bottom right, we have our um, picture of Pluto, and it's very distinct in my mind. I see this as a big heart area here. My brain kind of fills it in on the other side. It looks like a little heart, or a big heart actually, on the surface. So it's just very interesting to see all the different colors on the surface, and we are definitely still researching Pluto. Um, we've only had one flyby, which was actually pretty recent, and past few years, and that's where we got this image here. Okay, so let's go ahead and move on to debris in the solar system. So we have a few different types. First, I want to talk about asteroids. So this is an asteroid, okay? So think of it as like a minor planet. That's what it's sometimes referred to as, and it's rocky. And it doesn't have much air, so it's very, let's see, dense. It'll be more dense, and it is typically, or not typically, it is the remnants of early formation of the solar system. So it's just kind of stuff that was left over from the formation of the solar system. Then then we have comets, and these are sometimes called cosmic snowballs of frozen gases, rock, and dust that orbit the sun. Okay, and they have a very interesting orbit. I don't know if we'll see that here, but their orbits are very, very elliptical, very large. Okay. When they get closer to the sun, they heat up and spew gases, just like you see here, um, into some sort of what they call a giant glowing head, larger than most planets, and a dust trail behind it. So there's dust and gases that are making this tail, um, that stretch for, this says just from the sun for millions of miles. Oh yeah, so if the sun is here, it's stretching in the opposite direction, right? So this is the idea of a comet. So a comet has what they have here as like a head and then a tail. Okay, and we see these in the night sky ever so often. A really common one is Halley's Comet. Um, and asteroids we see if they get nearer to us into our uh, atmosphere and so forth. But we'll talk about that in a minute here. So this is going to be debris in our solar system, but this is going to be heading towards Earth. So we have meteoroids that are objects in space that range from the size of dust grains to small asteroids. Okay, and these are more rocky, um, more metallic, I would say. Meteors are meteoroids that have made it into our atmosphere, and they burn up into fireballs or shooting stars. And so this is what we see when we see shooting stars. Um, they're actually meteors in our atmosphere. Okay. Then we have meteorites, which is a meteoroid that survived the trip from space through the atmosphere down to Earth and hit the ground. So meteorites is what we see on the surface, on Earth's surface. And I just wanted to show you guys how large these can be. So this is me and my mom in New York City, in the Natural History Museum, and it has this huge, I mean, that's really large for um, our eyes, this meteorite um, on display, and anyone can touch it. It was really cool experience. So, yeah, so seeing how large they can be and also how small. Maybe this next week I can bring in a necklace that I have and it's a little meteorite on it. It's very small. Um, and a lot of times, um, we can find them after it rains. So this is sort of an interesting thing. Um, we have tiny meteorites constantly coming down into the atmosphere. Sorry, meteors coming into the atmosphere, burning up, and then coming down to Earth. But we don't necessarily see them all because they can be so small. They can be, like it says here, the size of dust grains. And by the time it comes here, it could be even smaller or just that size. So, after it rains, we'll have some dust that collects on our roofs. After it rains, it'll slide off into the gutters. And if you go and get some material or soil that is near that gutter, you can most likely find some meteorites. And getting a um, magnet uh, will help you kind of fish them out because they are metal. Um, and so if you get, a few pieces that might be it, you can then look under a microscope and see a lot of times these meteorites that have gone through that whole trip and are that small, they're usually very spherical, so they look like little balls or circles. So it's really interesting to see them under the microscope. That might be something we could do in the future. I'm not positive though, but something that's pretty interesting. All right, so I wanted to give you guys this one last look at our solar system. So obviously we have not gone in depth about the sun yet, but we will. But I wanted to give you guys kind of an overview of our solar system, including some stuff that I had not talked about. So we have our planets in order: Mercury, Venus, Earth, Mars. Those are our terrestrial planets, right? Terrestrial. Then we have the asteroid belt. So this is a region that is a collection of rocks and ice, um, and it is just a big collection of asteroids. So it's called the asteroid belt. And in this picture, it names a few of them. Um, that are actually named, but I'm not going to go through those. I just want you to know where it is in our solar system. So again, we have our terrestrial planets, then we have our asteroid belt, then we have our um, Jovian planets, which are Jupiter, Saturn, Uranus, Neptune. Then we have our Kuiper belt, and this is going to be a collection of methane, ammonia, nitrogen, water, and water ice, and any other kind of debris, okay, that would be way out here past Neptune. This is also where Pluto resides. Pluto resides in this Kuiper belt. So there's obviously some dwarf planets, possibly some other asteroids out here, okay? Here and here, those are comets. So you can see where comets could be coming from, where they could be going, okay? And then way out here is called the Oort cloud. Now, this is a cloud around the entire solar system. Doesn't really, I wouldn't say it really follows the whole orbiting motion of the solar system in a plane. It's kind of a whole cloud that kind of encompasses our whole solar system. So just know that that guy's out there too, just kind of surrounding everything in our solar system. Okay, so again, know that these are, let me write it in a different color because that way it'll stand out. Let's go with yellow. So we have our terrestrial planets. We have our asteroid belt. Then we have our Jovian planets and our Kuiper belt and our Oort cloud. Okay, so understand what is, our orientation here, the order of the planets. Think of some mnemonic devices. My very eccentric mother just sent us novels. Something like that. It used to be 9 pizzas, but Pluto is no longer part of the 8 planets in the solar system. It is a dwarf planet. So try to think of some the mnemonic device to remember that, and remember where the asteroid belt is, the Kuiper belt, the Oort cloud, and where we'd find maybe some asteroids, um, and so forth. All right. So next time we will talk about the sun, and not too far in depth, but a good idea to get us started with stars. All right. If you have any questions, as always, please let me know, and I will get back to you as soon as I can. Thanks.